Hi there, in this video we are going to talk about Outcome 5, Component 5, Part 2. We'll continue our discussion with rational exponents and radicals. So we're going to see a few more exponent rules that you saw back in Algebra 1, and then we'll switch things up a little bit, make them slightly harder for Algebra 2. So the first rule that we have is called the product rule for exponents. This says that when we're multiplying two terms that have the same base, so big idea here, they have to have the same base, so it could be like x to the 4th and x to the 7th, those have the same base. We could not do x to the 4th and y to the 7th because one has a base of x and the other has a base of y, so that one would not work. If we do have that same base and we are multiplying two terms together, we add the exponents. For example, if we have x squared times x to the 3rd, what we're going to do here is add those exponents. So I really have 2 plus 3, which gives me 5. Now we use this product rule for exponents all the time. I specifically think about it when we are distributing. So if I had, let's say, x squared and I was distributing it to x plus 1, x squared times x would become x cubed, and what we did there was just add those exponents. 2 plus 1 gives me 3. So now that we've learned about these fractional exponents, right, the rational exponents that have fractions, we can make this a little bit harder here. So I have a to the 2/7 times a to the 4/7. Again, I'm noticing that they have the same base. Both of them have base a, and they're being multiplied. So I'm going to take my base and keep it the same and add my exponents. Now, in order to add fractions, we do have to have the same denominator. In this case, the denominators are both 7, so I can add these just right away. The numerators are going to add together, so 2 plus 4 gives me 6, and my denominator stays the same. Again, if I can simplify this fraction, I want to. 6 over 7 cannot reduce, so this would be my final answer. Okay, another example here. I have b to the 5/6 times b to the 2/3. Again, both of them have base b, so I can keep that base the same and add my exponents. Now I'm noticing here that the denominators are not the same. One has a denominator of 6 and the other has a denominator of 2. In order to add these fractions, they do have to have the same denominator. So I'm going to do a little bit of work off to the side here, and I want to try and make these fractions have common denominators. Now the lowest common denominator between a 6 and a 2 would be 6. I could multiply a 2 by something to make it into 6. So let's go ahead and try to make both of these denominators 6. In order to make the 2 become a 6, I need to multiply by 3. So I'm going to multiply the top and the bottom of that fraction by 3. 3 times 3 gives me 9, and 2 times 3 gives me 6. Now we do not want to reduce there. If we reduce by dividing by 3, I'm right back to where I started with 3 over 2. So I'm going to leave that the same, and I'm going to write my first fraction. Now these fractions do have common denominators, so I can go ahead and add the numerators. 9 plus 5 gives me 14, and this is still over 6. So jumping back to my problem here, I now have b with an exponent of 14 over 6. Now 14 and 6, those can both reduce by dividing by 2. So I'm going to go ahead and divide them both by 2 here. My base stays the same, but I now have 14 divided by 2, which is 7, and 6 divided by 2, which is 3. Now what's nice about this here is you get to use your calculator on tests and quizzes. So I'm going to show you how you can check your work with this calculator. Now because b is a variable, I'm not going to be able to type that b into my calculator, but I could do this fraction work in my calculator instead. So what I'm going to do is just type in 5/6, and I'm going to show you a few ways to do this. One way that you could do it is to use your fraction template. So I'm going to hit alpha y equals and enter. Pulls up a nice little fraction for me. I was adding alpha y equals enter. And what's nice about that fraction feature is it changes it right into a fraction for you, so I have 7/3 there. Now some of the calculators don't have the ability to make that little fraction, so if your calculator won't do that, we're just going to use parentheses. So I'm going to write 5 divided by 6 in parentheses, showing me that that is one fraction, and then I'm adding 3 divided by 2, showing me that's another fraction. Now this gives it to me as a decimal. I definitely don't want a decimal as my fraction, as my exponent, so I need to change that decimal into a fraction. I can do so by pressing math on my calculator, and then enter for frac, enter one more time, and it should change it into 7/3. So using that calculator to check your fraction work is a great idea. Okay, my next exponent rule is all about fractional exponents in the denominator. So how else can we write x to the exponent of 1/2? Now we've said that we can change these fractional exponents into radicals. So if I were to change this into a radical, my base would be x. The denominator, or 2, is on the outside here as my index, and my numerator is the exponent inside. What must happen when there is a radical in the denominator? Okay, we've seen this earlier in this unit. I can never have a radical in the denominator. So we cannot have So because we cannot have a radical in the denominator, what we need to do is multiply by something so there are no more radicals in the denominator. Now because these fractional exponents are technically radicals, there's another rule here that says we cannot have fractional or fraction exponents in the denominator. Okay, so for example, if I do a problem and I get something that says 1/x to the 1/2, that's a no-go. That fraction exponent is in the denominator, so I could not have this. If I get x on top and I have x to the 2/3 on the bottom, again, that's a no-go. That fraction exponent is in the denominator. What about if I ended up with x to the 1/2 over x? Well, that one would be okay because that fraction exponent is in the numerator, not in the denominator. This exponent down here is just a 1, so that would be okay. Okay, you just cannot have those fractional exponents in the denominator. So let's take a look at example 2, part A. It says simplify each expression, and it gives me b to the -5/6. Now, I've learned so far that I am not allowed to have negative exponents. So to get rid of that negative, what we're going to do is change this entire thing into a fraction. I'm going to move the base, so b, and the exponent, so that 5/6, to the bottom of the fraction, and it becomes positive. It looks like there's nothing on top here, but there's technically a nice little invisible 1. Now this was a good start because I got rid of my negative exponent, but this cannot be my final answer because I have this fraction exponent in the denominator. I cannot have that. So what I need to do is somehow make this fraction whole. So what we're going to do is multiply by something. Now when I multiply here, I want to make sure that my base is the same. So I'm going to keep that b the same. I already have 5 out of the 6. If I think of this as like a pizza, I already have 5 out of the 6 pieces. My goal is to make this a whole number. So I already have 5 out of the 6. In order to make it whole, I would only need 1 more out of the 6. So I'm going to multiply by b with an exponent of 1/6. If I multiply by that on the bottom, I also need to multiply by the same thing on the top of my fraction. And when we're multiplying fractions, we're multiplying just straight across here. So on the top, I have 1 times b to the 1/6. 1 times anything is just itself, so this is just b with an exponent of 1/6. On the bottom, I have b to the 5/6 times b to the 1/6. This is what we just saw in those last examples. I'm multiplying. The bases are the same, so I'm going to add my exponents. 5/6 plus 1/6. Denominators are already the same, so that should give me 6 out of 6. Now it still looks like there's a fraction in that denominator. 6 over 6 can reduce to just 1. So I'm going to write this as just b. You could put b to the first if you wanted, but I still have that b to the 1/6 on top. Okay, this is what most of our answers will look like here. It's okay to have that fractional exponent in the numerator. That's totally fine, but we cannot have that in the denominator. Go ahead and take a minute to try. No, actually, we'll do part B together, just so we can see another one like that. So this one gives me x to the negative 3/5. Again, I don't like that negative exponent, so I'm going to change this into a fraction. The base and the exponent are moving to the denominator, becoming positive, and I'm left with a 1 on top. Okay, this cannot be my final answer because of that fractional exponent in the denominator, so I'm going to multiply by something to make it whole. I need my base to be the same, so I'm going to keep this in x. I have 3 out of the 5, but I want a full piece here, so I need 2 more to make it a full 5. Whatever I do on the bottom, I have to do on the top. And then we'll multiply straight across. So 1 times x to the 2/5 gives me just x to the 2/5. On the bottom here, I'm noticing I'm multiplying and they have the same base, so I can add my exponents. 3/5 plus 2/5 would give me 5/5. And again, 5 over 5 reduces to 1, so I just have an x in the denominator, and I have that x to the 2/5 in the numerator. Go ahead and take a minute. I want you guys to try 1 and 2, and then I will show you the answers. Right here are those answers for 1 and 2. 1 was a little bit tricky here. You started with the same base, so we should be adding those exponents. Don't forget about that subtraction, or that negative in front of the 3. It just kind of works like subtraction. So 1 minus 3 should give me negative 2 over 4, which then reduced into negative 1/2. Now you could also use your calculator there. So I did 1/4 plus negative 3/4, gave me that decimal, and then I changed it into a fraction. Now I can't have that negative exponent, so I moved it to the denominator. Now I can't have that fraction exponent in the denominator, so we multiply by the missing piece to make it whole. This was 1 out of 2, so I only need one more out of 2. And I end up with p to the 1/2 over p. 2 was a little bit easier than number 1. 1 had quite a few steps there. I'm going to start with getting rid of the negative exponent by changing this entire thing into a fraction, putting r to the 4/5 in the denominator. I'm left with 1 on top. Now I can't have this fractional exponent in the denominator. I already have 4 out of 5, so I multiplied by r to the 1/5. 4/5 plus 1/5 gives me 5 out of 5, which is just a 1. So you could put r or r to the first here. And on the top, we have 1 times r to the 1/5, which is just r to the 1/5. Again, I want to point out that it is okay to have these fraction exponents in the numerator, but you cannot have them in the denominator. Let's go ahead and turn our page and look at another type. Okay, the last exponent rule that we'll look at is called the quotient rule. This says that when we are dividing two terms that have the same base, so just like we saw with the last few, they must have the same base, we are going to subtract the exponents. So if we're dividing two things that have the same base, like in this example, we have x to the 5th and x to the 3rd, I'm noticing that base is x for both terms. We are going to subtract the exponents. So for this one here, my base of x will stay the same, but I'm going to take the numerator, so the exponent in the numerator, which is 5, and subtract the exponent in the denominator, which is 3. 5 minus 3 gives me 2. So I now have x to the 2nd. And the reason that we can subtract here is because that division kind of works like canceling out. So when I think of x to the 5th, I think of 5 x's all being multiplied together. 1, 2, 3, 4, 5. On the bottom, I have 3 x's being multiplied together. Okay, these two x's, x divided by x, will cancel. X divided by x will cancel. X divided by x will cancel. And I'm left with just 2 x's in the numerator. And because this is algebra 2, it can't just be that easy, right? We have to make things a little bit harder with some fractions or some negatives. So we'll see what these look like through the next few examples. Okay, part A here gives me y to the 1/2 divided by y. Now I do notice that those have the same base and they're being divided, so we can go ahead and subtract our exponents. This y in the bottom doesn't have an exponent. If you don't see one, it's a nice little invisible 1. There's just one y right there. So I'm going to write my base. My base is y. And then I'm subtracting my exponent. So starting in the numerator, I have 1/2. And then I'm subtracting the denominator exponent, which is 1. Now again, I could do some fraction work off to the side here. If I have 1/2 minus 1, I can really make that 1 over 1. It's dividing by 1, doesn't change anything. And in order to subtract, I do need these to have the same denominator. So I'm going to multiply the second fraction by 2, making it 2 over 2. 1 minus 2 gives me -1, and my denominator is still 2. Again, if you want to check that fraction work with your calculator, you definitely can. We would type in 1/2 minus 1, change that back to a fraction, and it gives me -1/2. So my base is still y, but now I have an exponent of -1/2. And now from here, to continue to simplify, I am going to have to use all of those other rules we've seen. I cannot have a negative exponent, so I'm going to change this into a fraction. My base and exponent are jumping to the denominator and becoming positive. There's a nice little invisible 1 on top. I still cannot leave this as my final answer because I can't have that fractional exponent in the denominator. So I would go ahead and multiply by y to the 1/2. Again, I need one more to make it whole. 1 times y to the 1/2 is y to the 1/2. And on the bottom here, I have a half plus a half, which gives me a whole. Now this really wasn't the best example for us to start with because my simplified answer was actually the answer that we started with. Most of the time what you'll see here is that they will give you a fractional exponent in the denominator, so that simplifying should help get rid of the fraction in the denominator. Okay, let's take a look at part B. Again, I'm noticing I have x to the 7th divided by x to the negative 1/2, same base there. So I'm going to keep my base. We're dividing, so we subtract exponents. So I have 7 minus the negative 2. Those two negatives do make this a plus sign, so I'm really adding here. So 7 plus 2 gives me 9. Am I allowed to have 9 as my exponent? Yep, it's not negative, it's not a fraction in the denominator, so my final answer is x to the 9th. On the bottom of this page, we have some mixed practice, kind of going through all of the different exponent rules that we have learned today. Go ahead and take a minute to try these few problems, and then I will show you my work with my answers. Here is my work for those 6 practice problems. A few of them I did want to talk about just real quick. Number 3 is just using that exponent rule. When you are multiplying with the same base, your exponents add, so we get 6/7. Make sure you pay attention to the directions. They did want you to write your answer in radical form, so once you have a to the 6/7, you do need to change it into radical. And number 6 did not have any variables. It was all numbers, so no variables here, which means we could check our work here fully on our calculator. So we could type in 81 with an exponent of negative 1/4. And when I change that to a fraction, it does give me 1/3.